In the world of artificial intelligence, there's been this one simple rule that's driven a massive, multi-billion-dollar arms race for years. Bigger is better. The whole idea was that to get a smarter AI, you just had to build a bigger one. But what if that core belief, the very foundation of this entire race, was actually wrong? Let's dig in.
Let me put it this way. To become an expert, what's better? Having a gigantic, super complex brain but only reading a few books, or having a smaller, more efficient brain that's read, everything in the Library of Congress? This is the exact question that has completely reshaped how we think about building powerful AI. So where did this whole bigger is better idea even come from? Well, it wasn't just a random guess. Back in 2020, researchers at OpenAI dropped this incredibly influential paper that seemed to give everyone a clear, predictable roadmap for making AI more and more powerful.
And this quote right here, this was the heart of it. The paper showed that as you just poured more resources into these models, more data, more computing power, and especially a bigger model size, their performance just kept getting better. And it did so in this beautifully smooth, predictable curve.
And this chart, this was basically treated as gospel. It suggested there was this kind of power law for AI. You see this line smoothly going down? That means as you crank up the size, data, and compute, the model's error rate just keeps dropping. For the entire industry, this became the treasure map, a simple recipe for building smarter AI.
But here's the most crucial ingredient in that recipe. It said that if you get a bigger compute budget, you should spend almost all of it on making the model itself bigger, increasing its number of parameters. The amount of data you train it on, that could grow much more slowly. So going back to our analogy, the advice was build a bigger brain first, the library can wait.
Okay, but was that recipe really balanced? To understand what happened next, we need to quickly break down the three key ingredients that everyone in AI is constantly trying to juggle.
Think of it as a constant balancing act between these three things. First, you've got model size. That's the raw complexity of the AI's brain. Then there's the training data, which is the library of information it gets to read and learn from. And finally, all of this is limited by your compute budget, basically the total energy you can afford to spend. The whole game is figuring out the best way to spend that budget, because you can't just maximize all three at once.
So for 2 years, the entire industry just ran with this bigger brain recipe. And then in 2022, researchers at DeepMind published a paper that changed, pretty much everything. They decided to put that old rule to the ultimate test.
And when I say they put it to the test, I mean they went all out. They trained over 400 different models, playing with every variable you could imagine. Models from 70 million parameters all the way up to 16 billion, and they fed them anything from 5 billion to 500 billion tokens of data. It was just a massive, systematic effort to find the true optimal recipe.
And what they found was absolutely revolutionary. The old rule suggested that for any given amount of compute, you should just build the biggest model you possibly can. But what DeepMind discovered after all those experiments was the exact opposite. They found that the best performing model was consistently smaller and had been trained on way more data than anyone had thought was necessary.
So let's just put it side by side. The old rule from 2020 said if your compute budget doubles, you should make the model size grow the most. The new rule, the chinchilla rule from 2022, says that if your compute budget doubles, you have to grow the model size and the data size equally. It's all about balance. Now, I know this might all sound a bit abstract with scaling laws and whatnot, but DeepMind made this incredibly real by setting up a direct showdown. Think of it like a title fight between two AIs, built with the exact same budget but following two totally different recipes. In one corner, you have Gopher, an absolute behemoth at 280 billion parameters, built with that classic bigger is better philosophy. In the other corner, you have Chinchilla, which is 4 times smaller, only 70 billion parameters, but it was trained on over 4 times more data. We're talking a staggering 1.4 trillion tokens. And remember, both cost the exact same amount to train.
So, who won? Well, they tested them on a massive benchmark called MMLU, which is like a final exam across 57 different subjects, everything from law to computer science. And the smaller model, Chinchilla, didn't just win, it absolutely smoked Gopher, beating it by a massive 7.6 percentage points.
And this chart right here just shows you how decisive that victory was. It says it all. The smaller model with the bigger library was just significantly more knowledgeable. A smaller brain that read more books was simply smarter than the giant brain that hadn't read as much. Case closed.
Now, this wasn't just about one model beating another in some competition. The chinchilla discovery sent a shockwave through the entire AI world. It fundamentally changed the blueprint for how you build state-of-the-art AI systems.
And this discovery really is a game changer. I mean, first, it's way more cost-effective. You get better performance for less money and less energy. Second, it democratizes the field. Suddenly, you don't have to be a tech giant to afford to build and run a top-tier model. It also shifted the whole industry's focus. The race wasn't just for the biggest model anymore, it became a race for the best, highest quality data. And finally, this all points to a more sustainable and efficient path for the future of AI.
So, the story of chinchilla is just a classic tale of scientific progress. You have a widely held belief, backed by data, that gets completely overturned by an even bigger, more careful experiment. It's a powerful reminder that in a field moving as fast as AI, our most basic assumptions are always up for debate. Which kind of makes you wonder, what's the next bigger is better myth that's just waiting to be busted?